Hello, good afternoon, students. I hope you all are doing good. Okay, so in today's class, we are going to discuss something very most important about some of the properties in the periodic table. Then we'll discuss about chemical bonding. Okay, so guys, I hope everyone is doing good. In the last class, we all are doing about periodic table. About we have learned about diagonal relationships, screening effect, okay, inert pair effect, but there is some bit doubts in inert pair effect. I told you to not to worry much about it. So basically, I have mentioned the inert pair effect here, right? So in the inert pair effect, down the group, what will going to happen? Size will increases, and ionization also decreases down the group. Okay, so the reluctance of pair, or we can say the reluctance of involvement of ns2 pair of electrons is simply nothing but inert pair effect. So we have discussed that one. So this is the best explanation I feel. So that's why I kept here. So take your time and try to read this one. Take the screenshot if possible. Okay, so you'll get an idea about this one. Okay, so I'll tell you simply what is happening in the this one. Okay, so there are n minus 1 d electrons and ns electrons. So due to poor shielding of this one, due to poor shielding, what will going to happen? This ns2 electrons will penetrate inside. So when they are penetrating inside, that means they are near the nucleus. Okay, they will pull towards the nucleus. So due to the pulling towards the nucleus, the z effective over this electron, the z effective over ns2 electrons increases, and they are very you know poor to participate in the reaction. They are very poor to participate in reaction. So which is simply nothing but what? They are ready to, they are unable to come out of it. So only let's suppose this is going to observe for the period number 4, 5, 6, and 7. Okay. So 4, 5, 6, 7, all the elements which are present in the P block from the 4, 5, 6, 7 will undergo this one. So in the groups, P block elements, let's suppose if I'm talking about germanium, okay, tin and lead, and before that gallium, indium, and thallium. And we have also seen what is that? Arsenic, antimony, and bismuth. Okay, so in these 9 elements, we are going to see the inert pair effect. Generally, if you see the gallium, so gallium will exhibit in +3 state because the outer electronic configuration ns2 np1. Okay, but gallium and indium and thallium, these all are exist in +3 state. Okay, but the interesting fact about this one is the +3 state is highly unstable compared to +1 state. So +1 state is more stable in this case. But usually what will happen, gallium which is in +3 state is more stable than +3 state. Down the group, what is going to happen? Size will increases, and the higher oxidation state stability will be decreases. But whereas in case lower oxidation state, stability will be decreases down the group. So that's why Ga+1 is stable than indium +1. Ga+1 is less. Just a minute. Ga+3 is more stable than indium +3 and thallium +3. But if we are going to see that one, gallium +3 is less stable than indium +1 and thallium +1. So +1 oxidation state down the group will increase the stability of the ions. I hope you guys understand about this one. And another, because of this, compounds exception is this. Compounds like BiCl5, BiI5, BiBr5. Okay, these are not going to exist because bismuth in +5 oxidation state is unstable compared to bismuth which is in +3 state. Why? Because Bi +3 state is stable because of inert pair effect, and bismuth +5 is not going to be there that much easily. That is because of inert pair effect only. So these are not going to exist, but BiF5 exists because of strong electronegativity of fluorine. They are going to exist. Simultaneously, PbF4 exists, but PbCl5, Cl4, PbBr4, and PbI4, these 3 compounds will not going to exist because lead in +2 state it is more stable, but not in +4 oxidation state. Okay, again, higher electronic configuration, more electronegative compounds will going to be formed. Okay, and next one, if you see from the next compound, if you see that like TlF3 will not going to exist, TlI3 is not going to exist, and TlBr3 is not going to exist, because Tl+1 state is more favorable rather than Tl+3. So another very most important of you people need to remember is Tl+3 plus I3 minus. This is ionic compound, exceptional case. So this is exist. This is stable. This can be exist. But TlCl3, TlF3, TlBr3 is not going to exist, because thallium in +1 state is stable than thallium +3 state. In all cases, this is in +3, +3, +3. So these are unstable, but only +1 state is stable because of inert pair effect. I hope you guys understand what are the compounds can exist, what are the compounds not exist. Okay. Yeah. Yes. So this is very, very most important. Yeah. So that's it, guys. Next, ionic radii. Ionic radii is simply two types. One is cationic radii, another one is anionic radii. So what is cationic radii and anionic radii? Cationic radii is simply nothing but when we remove an electron from the neutral ground state atom, it will form a cation. Whenever the neutral atom is gaining one electron, then it will have an anion. Okay. Just a minute, guys. Let me check the YouTube whether it is running or not. There is no problem from the YouTube. YouTube participants are there. They are watching the class. So there are nothing to worry about it. Yeah. So now, right. So now it is pretty clear that, so if you are removing one electron, it will become cation. If you are gaining one electron, it will become anion. So the size will increases if you are gaining one electron, because it will add into the new cell. And the size will decreases because the electron has been removing, the number of cells will decreases, the size will decrease, and the effective nuclear charge increases, because as the size is decreasing, the electron will be near to the nucleus, will pull towards the nucleus very nearly. So effective nuclear charge on that particular electron will increases. Simultaneously, repulsions will increases. Okay, but effective nuclear charge decrease. What are repulsions? Let's suppose this is an inner electron and this is the valence electron and this is the nucleus. So these are the inner electrons and nucleus. So you know that the repulsion between these two electrons increases, and the repulsion between these two electrons increases, and the positive charge and the negative charge. Okay, electron is negative charge. Okay, so that's why Z effective will decreases. Why? Because the repulsions are bit dominant compared to the cations. And if anyone asks, what about the general size order? Is cation is less stable than ground state than anion? I hope you guys understand the reason for it. Okay. Yeah. Next one, if you go, right, isoelectronic species, which is very, very most important for your JEE mains examination and NEET examination. Isoelectronic species are simply nothing but they are having same number of electrons in their valence shell. Same number of electrons in their valence shell is simply nothing but called as isoelectronic species. And what are them? If you see here, F minus, Na plus, and O2 minus. Some of the examples, if you can take N3 minus, O2 minus, F minus, Ne, Na plus, Mg plus 2, Al plus 3. So these all are the isoelectronic species. They all are having 10 electrons. But in your examination, they don't ask what are isoelectronic species. They will ask with a different type of questions. What are those? We'll see. Okay. So if you see uh, the comparison between the sizes. Okay. So very most important for isoelectronic species, as the number of Z value increases, number of protons increases, Z effective over outer electron increases, so the size will decreases. Very most important. These are the points very most important. In case if you are dealing with the isoelectronic species, if anyone asks about the size of isoelectronic species order, just simple, जिसका z value ज्यादा है उसका radius कम होगा. क्यों कम हो रहा है? Z effective will be higher. So best example I can give you. Yes, so these are the some series of isoelectronic species. So the atomic number which is having higher will have the lower atomic size. So let me give you one example here. Let's suppose if I want to ask ask for the order of ionic radius. Order of ionic radius, if I am asking you, then what you are going to see this one? N3 minus will have more size than O2 minus, then F minus, Na plus, Mg plus 2, and Al plus 3. Why? Because as the Z value increases, Z effective increases, ionic radii of isoelectronic species decreases. Okay, only for isoelectronic species. Some of the other isoelectronic species are like what? Cl minus, S2 minus, and P3 minus. Okay, then what is that? K plus and Ca plus 2. So these all are having 18 electrons, if you can see. These all are having 18 electrons in the outermost shell. So these all are what? Isoelectronic species. Simultaneously, there are some other compounds. Please do check. Okay, like CO. CO means what? 6 plus 4. 6 plus 4, this one. And next, N2, 14. Here, how many electrons? 14 electrons is there. And here, how many electrons? 14 electrons is there. So both are isoelectronic species. So isoelectronic species are simply nothing but where they are having same number of electrons. Where they are having same number of electrons. Okay, I don't know why in June many students have not joined. I don't know. Yeah, I think if any student is missing, you can watch from the YouTube later. But if people try to understand this one, okay, I don't know why many schools have missed. Next, we are talking about ionization enthalpy. So ionization enthalpy is very simple and very easy to remember. That is the minimum amount of energy required to remove an electron from the isolated gaseous atom. So if you want to remove an electron from here, so that is at the valence shell, you need to be take the atom into the gaseous atom. Why in gaseous atom? Because in gaseous atom, the space availability will be very high. So it is very easy to remove the electrons because the atoms are the molecules present inside the gas phase are loosely bonded. So electron removal will be very easy from that one. Means minimum energy is required to pull the electrons in the ground state, and that too in isolated atom. Okay, now then what is the meaning of ionization enthalpy? Means you are removing an electron. So how you are removing electron? You are giving the electron. Okay, so you are giving the electron here. So upon giving, or we can say upon supplying the energy, the electron has been removed. So ionization enthalpy is always endothermic in nature. Ionization enthalpy is always endothermic in nature. Okay, ionization enthalpies and other in nature. Okay, so very most important. Yeah, so 8 double. YouTube class is running, but I don't know about Zoom. What happened to Zoom? Right, nothing to worry about this. So ionization enthalpy is simply nothing but the minimum amount of energy required to remove an electron from the isolated gaseous atom. So next, very most important, ionization enthalpy is always positive as energy is required. Okay. Next one, ionization enthalpy. If you are removing two electrons, so first that we call it as IE1, and the second, if after removing, that is IE2. So we can, if you are removing the electron from Mg plus, that is called as IE2. Agar if you are removing from magnesium and you are making Mg plus, so then this is IE2. Okay, so this is IE1 and this is IE2. So always remember IE2 will be higher than IE1, always. Okay, IE2 will be higher than IE1. And remember the overall ionization enthalpy is simply nothing but delta I H1 plus delta I H2. Okay, that is IE1 plus I2. IE1 plus IE2. So very most important ionization enthalpy. And we already know ionization enthalpy from left to right. What will going to happen? Increases from top to bottom, it will decreases. There are some exceptions, very most important exceptions you will observe. Okay, because of screening effect. Okay, because of screening effect. And next one is due to the penetration effect. Due to penetration effect. Okay, so there are some exceptions we are going to see. So very most important, ionization enthalpy is directly proportional to Z effective and inversely proportional to जितना ज्यादा screening effect होगा उतना ionization enthalpy होगी. So that is inversely directly proportional to Z effective. No, inversely proportional to Z effective, because more the Z effective, the electron will be stable. Just a minute. Ionization enthalpy is directly proportional to Z effective and it is directly proportional to atomic size. जितना atomic size होंगे और उतना उसका कम energy लगता है. So that is we can answer say that higher the atomic size, lower will be the ionization enthalpy, and it is directly proportional to screening effect. More the screening effect, okay, screening effect जितना ज़्यादा होगा means how they are more the screening, valence electrons can easily go out. Okay, more will be the screening, less will be the ionization enthalpy. So we can clearly say that this is inversely proportional. But there are some exceptions like lithium, beryllium, boron, carbon, like that. If anyone is asking, okay, what is the ionization enthalpy order? Beryllium is 1s2, 2s2, and this one is 2s2, 2p1, 1s2, 2s2, 2p1. And here it is completely filled and it is singly unpaired electron. And completely filled and high penetration effect, beryllium is having more IE enthalpy than boron. But compared to lithium, beryllium is having higher, but boron it is higher than for carbon, and it is normal only. And same oxygen, nitrogen, fluorine, if you take, compare with the oxygen, fluorine is having more capacity, and comparing with the fluorine, nitrogen having more atomic number. Sorry, nitrogen, oxygen, and fluorine, and before that carbon. So compare with the carbon, it will be higher. Compare with the oxygen, it will be higher because of half-filled configuration. Because of half-filled configuration. So because of half-filled configuration, this is the order. So the overall order for the ionization enthalpy is Li. Then we are having beryllium. Okay. We are having boron, then beryllium, next carbon, oxygen, nitrogen, fluorine, sodium, and same you will observe in the magnesium case, so aluminum and magnesium. So this is the order of the ionization enthalpy. So ionization enthalpy order will be like this. Okay. And next, moving forward, electron affinity. What is electron affinity? Electron affinity or electron gain enthalpy, both are same. So whenever is there any isolated gaseous atom, if we are trying to give an electron or if it is trying to gain one electron, the size of the ion will increases, or we can say the size of anion will increases because the addition of electron. Simultaneously, some repulsions will be takes place between the inner electrons and the outer electrons, but the like addition of electron will not have that much what you say inner electron repulsion, so that's why electron addition is easy. Okay, so we can say that what is electron gain enthalpy? The minimum amount of energy released after gaining one electron. So here after gaining one electron, it is become x minus. I hope you guys are clear. And this is also called as first electron gain enthalpy. Okay, we can also call it as EA1. So EA1, after adding one electron, there is a release in energy takes place. After adding an electron, there is release in energy takes place. So always remember, electron gain enthalpy is always exothermic for certain species. Okay, generally. But in case of noble gases, okay, so the electron affinity is positive. Okay, but all other other than noble gases, the electron affinity is negative. So that means what we can say, electron gain enthalpy neither exothermic nor endothermic. Okay, electron gain enthalpy neither exothermic nor endothermic. Okay, I don't know what happened, but we can't see. Okay, so sorry for the disturbance, guys. Right. So electron affinity can neither be like endothermic nor exothermic, depends upon the situation. But for the noble gas, they are already stable. So if you are adding the electron, it is required for you to give some extra energy to add an electron. So that's why for the noble gases, it is endothermic in nature. And other than that, very most important, there are some exceptional cases. You can clearly observe here. Rubidium, potassium, and cesium, their electron affinity values are nearly same. So very most important in your JEE and NEET exam. So among the following, which of the species will have same or nearly same electron affinity? That is potassium, rubidium, and cesium. These three are having same or nearly same what do you say that electron affinity. But whereas in case if you see for the oxygen and sulfur and fluorine and chlorine, there is a difference in the release in energy. The reason, because only simple thing. What is the reason for them? The reason is, yeah, first let me tell you, down the group atomic radius increases, delta G will be decreased as simultaneously as the ionization enthalpy. Okay, from going from left to right, effective nuclear charge increases, electron affinity will increases. Simultaneously, electron affinity increases as the effective nuclear charge increases. Okay, exceptionally high Okay, this is high negative enthalpy for the halogen elements because of the higher size. Now we can clearly say down the group electron affinity is the same as ionization energy. Now some of the anomalies you can see here. Okay, what is the some of the anomalies? Oxygen is having less electron affinity and fluorine is having less electron affinity over chlorine. That means group second and group third period में period third period में इस दोनों के बीच में anomalies है और इन दोनों के बीच में anomalies है. What are those? That is the reason because small size and electron cloud repulsion is higher. So that is why this is exceptional. So very most important electron affinity, all EA1 values are neither positive nor negative. That is neither endothermic or exothermic. And another important thing, EA2 are all are endothermic because of the addition of electrons, the inner electrons will increases. If you are trying to add an electron, repulsions will dominate. So that's why they are endothermic in nature. And EA1 are endothermic in case of what? Noble gases. In case of noble gases. Next, third one is electron affinity is same for electron affinity is same or nearly same is for potassium, rubidium and cesium. This is 46, 47, 48 energy release hoga. Next one is argon and krypton. Same, these two species are also having near electron affinity values. And next one is exceptions. Next one is very good exceptions. Exceptions in group 16. Group 16, sulfur is having greater silurium, tellurium, polonium, and oxygen. For group 17, chlorine is greater than fluorine, then bromine, then iodine. Okay, just remember these are very, very most important for your examination point of view. Because why sulfur is having higher compared to oxygen, why fluorine and chlorine? Because of small size. Okay, because of small size and greater repulsions. Because of small size and greater repulsions. Okay, I hope you guys understand what is the meaning of this one. Okay, so these are the exceptions from electron affinity where you can easily remember. Next one is amphoteric oxides. What are amphoteric oxides? Amphoteric oxides are basically, these are the amphoteric oxides. Amphoteric oxides are basically metalloid से form होता है except this one, what we call silicon. Silicon is a metalloid, but it always form acidic oxides. It is always form acidic oxides. So there is an often perception that amphoteric oxides are formed by the metallic element. Metalloids. No, wrong. What is metalloids? Which can act as both metal and non-metal. So that means they may also similarly we can think that they may act as both acidic oxide and basic oxide. So that's why we can call them as amphoteric oxide. So silicon is metalloid, but still it exists only in the form of acidic oxide, but not in basic oxide. So that is why it is not amphoteric. And so in group 2, beryllium oxide and aluminum, gallium trioxide, tin and lead as lead. This one is antimony, and then tellurium and polonium. These all are the amphoteric oxides. Very, very most important. Other than that, ZnO and PbO. These two are also amphoteric oxides. So these amphoteric oxides are simply nothing but they can form compounds with both acids and bases. For those compounds, we call them as amphoteric oxide. We call them as what? Amphoteric oxide. I hope you guys understand this. So these are the regular trends for the periodic table. From top to bottom, atomic radius increases, and from left to right, atomic radius decreases. Yes, metals and non-metallic character across the period, non-metallic character increases. Down the group, metallic character decreases. Okay, and usually metals form basic oxides, non-metals form acidic oxides. I hope you guys are understanding this. Okay, now next. Yeah, what is anything is need to discussed in periodic trends? Almost we have discussed everything. Nothing much to worry about. Yes, chemical bonding. What is the meaning of a chemical bonding? Can anyone tell me? What is the meaning of a chemical bonding? Chemical bonding is simply nothing but whenever any two particular species is there. If you are making a bond between them, how this bond is happening? Because these are the force of attraction between both A and B. So bond is simply nothing but the force of attraction, or we can say the togetherness. Okay, the attractive forces among the constant ions in order to form compounds are simply nothing but chemical bonds. So there are so many types of bonds. One, we will study about covalent bond. Okay, next one is ionic bond. Third one is metallic bond. And fourth one is what? Covalent bond, ionic bond, metallic bond, and van der Waals force of attraction. So these are the some of the types of bonds which will be formed among the compounds. So how they are forming, why they are forming, we are going to study in the chemical bonding structure. Okay. I don't know why only one participant has joined. We will see. Already the time is up. 5 minutes more. Okay, so I will teach till 5 minutes. First of all, what is the meaning of octet rule? So here we need to study about octet rule. So what is the meaning of octet rule is whether the central element or the element, they should have a stable inert gas configuration or octet configuration within their periphery. So best example, if I am talking about H2, how the H2 is forming, H is having one electron, another H is having one electron. Both will share the two electrons. Okay, both will share the two electrons. Now each element will got two electrons within it. So two electron system is simply nothing but they are duplet. Duplet is also one type of noble gas configuration. So that's why they are stable. Simultaneously, let's suppose CH4 if you take. So carbon is having how much valency? 4. Carbon is having valency 4. Yes or no? Right? Carbon is having valency 4. So now if you see the outer electronic configuration, or we can, if you want to calculate how many bonds it has making, whether it is satisfied with the octet rule or not, you can check. That is 1, 2, 3, 4, 5, 6, 7, 8. So this is satisfying the octet rule. Okay, so octet rule satisfied. Now if you see hydrogen, will always accept the, what we are going to call them as, they are going to call them as duplet configuration. Okay, this is about the octet rule. So octet rule, another most important is like they help us to write the Lewis dot structures. Okay, so let's suppose lithium 1, beryllium 2, boron 3. So the valence electron will help us to find the valency of particular element, or we can say the ability to form the bonds can be predicted by using this particular octet rule. Okay, so I hope you guys understand what octet rule. Right. Next one, if try to draw the Lewis dot structure for CO2. Okay, try to draw the Lewis dot structure. I hope it has been teached in your schools, but still we are teaching about the Lewis dot structure for CO2. So then you will understand this one very clearly. Okay, so next, if we are talking about ionic bond. So first of all, we are talking about what? Ionic bond. So how the ionic bond is formed? So the ionic bond is formed by simply by transferring of electrons, So electron transfer करते मिल गया था. Let's suppose sodium Na plus and Cl minus. So that is sodium is giving it transferring its electron completely to chlorine. So that's why there is a charge has been developed between sodium and chlorine. Okay. Yeah. Right, between sodium and chlorine. So the transfer of electrons between the sodium and chlorine. So now what are the favorable conditions for ionization enthalpy? The favorable condition are it should have a low ionization enthalpy and the electronegativity difference should be higher hona chahiye. The electronegativity difference between A and B should be higher. And next, third one is high electron affinity. High electron affinity. So what is low ionization enthalpy? Low ionization enthalpy of metals and high electron affinity for the non-metals. I hope you guys are clear with this. Okay, so that's it guys regarding the ionic bond. We will discuss about those things in the